Okay, I'm an engineer and geologist by profession. I've been at CSR now for 36 odd years, and I've been doing research full-time for all this time in various aspects of roads, specializing for quite a long time in unsealed or gravel roads. And obviously this moves on to low-volume paved roads and then ordinary paved roads. My interest in potholes really started with gravel roads, because once they form, it's very difficult to get out. And it's just sort of carried on as I moved into paved roads. I did a PhD through the University of Pretoria on gravel road materials and performance. It probably is. I think our CEO or president of CSR, he turns up in Parliament a couple of times a year, and in the early stages, end of 2009, early 2010, each time I went to Parliament, everybody said, what is the CSR doing about potholes? And essentially, we don't fix potholes. That's not our job. We do research and some initial training and then hand it over to people like the South African Road Federation to carry on the training. But the message came back that this was a worry to government. And so we decided to do this project to just put together the information that we gained over the years into a document which would hopefully help reduce the pothole problem. I think it was a pretty wet summer season we had up here in the Highveld. And as we'll probably talk about shortly, water and roads don't combine under traffic. So with the excessive rainfall, fairly extended periods of fairly heavy rainfall, the roads started deteriorating. Potholes increased far more than in previous years. And basically the repairs couldn't keep up with them. So they became this visible, high-profile problem countrywide. Up until 2009, there have been a couple of fairly high-profile claims against road authorities for potholes, damage to vehicles, accidents on bicycles, for instance, things like that. But it was a fairly lengthy court procedure to go through this. I think in 2009, 2010, where the damage was more tires, rims, some minor vehicle damage, people realized they could claim from municipalities, road authorities, and the claims started coming in. But apparently the authorities were suddenly saddled with all these claims, and they admitted responsibility in many cases and didn't even argue, paid up. Yeah. Not at all. We have seen in literature, the UK for instance, Australia, over the last couple of years have also experienced extensive development of potholes, and in monetary terms far more than we actually need to put in to repair them. So it's not unique, but it's a legacy of cutting back in funding over the years, basically, in terms of preventative maintenance. If you Google potholes, you get quite a few million hits immediately, but they tend to be predominantly from America and Europe. And the origin or the cause of potholes in those environments is somewhat different to ours. There, where you have the so-called spring thaw at the end of winter, when the frozen water in the road starts thawing out, it affects the road, softens the material in the road, weakens the road, and heavy loads on that type of material lead to potholes. That's not the kind of pothole we get in South Africa. The whole road network, right from the early 40s, 50s, when they started paving it, we use much thinner asphalt and thin chip seals, or spray seals as they're called. In Europe, it's not uncommon to have 100, 150 millimeters of asphalt surfacing on a road. Here, the maximum would typically be about 50, often 25 to 40. So our pavement structure is very different, primarily because of the drier, warmer environment. We haven't got the cold conditions in winter. Okay, asphalt roads are roads that are paved with a mixture of stone and bitumen. And there can be two kinds. There can be asphalt, which is made in a hot mix plant at high temperatures, is placed in the road at high temperatures, a combination of usually aggregate, sand, bitumen, and some cement or lime or something. The other kind of paved road we get is the thin bituminous surfacing, where you spray a layer of bitumen on the road, you put stone on that, you roll it in, and that's basically it. Sometimes you can have two different size stones to make the seal. Tar we don't use anymore. It's basically banned for use on roads in South Africa. It is carcinogenic. It's derived from coal, where bitumen is derived from oil. That's the main difference. And then concrete roads. In South Africa, we've probably got maybe 4 or 5% maximum of concrete roads, and a totally different process, which is cement, aggregate, sand mixed together. Right, a good asphalt road is designed to last for probably 12 or 15 years with minimal maintenance. If the pavement layers are correctly selected, the materials, the pavement balance is right, the asphalt is right, and everything's constructed properly, they should last at least 12 to 15 years without any maintenance. If they're not maintained, the asphalt starts drying out and shrinking. It goes from the darker sort of blackish color to the gray color, and it becomes stiffer as the bitumen volatiles evaporate. It gets stiffer, which allows it to deflect more under traffic, and it basically generates fatigue cracking just from this repeated bending up and down under traffic. So that's the cause of cracking in an asphalt road, which ultimately leads to potholes when the water gets in the cracks. Okay, there's a whole lot of different ways that cracking forms in asphalt. Obviously, one of them is if you've got poor drainage. Next to the road you get ponding of water. It could be from irrigation or seepage from a stream or dam, or even often in informal settlements, just the general drainage ends up seeping into areas next to the road. If that water lies there, it can soak into the road, the structural layers beneath the asphalt, weaken those layers, so your deflection under traffic is even higher, so the fatigue cracking is quicker. And it's really like bending a wire backwards and forwards. You bend wire, it gets hotter and hotter, and eventually it'll break. And that's what happens to a road. Just this, under every vehicle, there's some kind of movement, vertical movement. And a really good strong road may be 0.2 or 0.3 millimeters. Other roads may be 0.8, 1 millimeter. We've measured even 2.5 millimeters in some very light pavement structures. Obviously, as a vehicle goes across, that movement, the effect of that movement on the bitumen or the asphalt is exactly like the effect on a wire, and ultimately it will crack. Yeah, aging affects bitumen, as I mentioned earlier. The bitumen is placed hot, so it's refined, it's made at the factory, it's delivered to site at anything 130 degrees upwards. It's sprayed on the road and it cools down. Immediately it starts cooling. It starts oxidizing just from the oxygen in the air and the ultraviolet light. It starts aging, losing the volatiles which keep it flexible, a lot of the chemical compounds which actually evaporate with time. And this causes stiffening of the bitumen, which whether in a thin bituminous seal or an asphalt, causes stiffening of that layer, which makes it more prone to fatigue. When we don't have some particularly good materials for the pavement structure, it's not uncommon to get a material that you can improve by the addition of cement or lime. And that's what we call stabilization. And you can make a weak material almost into a weak concrete, which is much stronger than we need in a road in many cases. When we add the stabilizer, be it lime or cement or a whole lot of other things as well, it absorbs water from the layer to hydrate that and causes some formation of cementitious products, which causes shrinkage of the layer, which causes cracking. And frequently driving in a road, you'll see this typical block cracking. If those cracks aren't sealed, the water can get in. What we do know is that those cracks, even in the subbase, which is one of the support layers, above the subbase you'll have a base course, which could be a G1 very good stone base, and then your surfacing. those cracks can actually reflect right through the G1 and through the asphalt or any other surfacing and appear at the surface. And that's when they need to be sealed with a special bitumen rubber or something to stop water getting in. If water gets in, it runs through the crack, through the base, through the sub-base into the subgrade, and you're back with the weak support layer. This is a big problem, traffic. Over the years, we've seen from 10, 15, 20 years ago, we had sort of 2-3 axle trucks. Now we've got literally hundreds of these 7-axle interlinked trucks. The ones traveling on the main roads, the weight is controlled pretty well, so they tend not to be overloaded. But the ones on the back roads and the less important roads where there's no overloading control tend to be overloaded. And the effect of an overloaded axle is extremely detrimental to roads. The damage is a little formula. The weight of the axle over 80 kilonewtons, which is our standard legal axle load limit, to the power 4.2. So any overload is increased to the power 4.2, which has enormous effect on the way that road handles that load. Right, when we were doing this document, we noticed there were different kinds of potholes in asphalt and thin bituminous surfacings. The thin bituminous surfacings in South Africa probably make up 95% of the bitumen paved road network. Apart from the main metropolitan areas and the national highways, the N1s, and even not all of the N1, but most of it, those are paved with asphalt. Everything else in this country is paved with what we call thin bituminous surfacings. And these vary from 5 millimeters or so for a sand seal up to probably 17, 20 millimeters for a double chip seal with a slurry on top or something like that. So they do differ in the way they fail and perform from an asphalt. A typical thin seal, a single seal should last 7 or 8 years before it needs some kind of maintenance. A double cape seal, which is a seal plus a slurry seal, they should last 10, 12 years compared to an asphalt, which is probably looking at 12 or 15 years. So they need more maintenance. Yeah, as mentioned, often the top of a stabilized layer becomes weak. And essentially, cement or lime, which you use for stabilization, they're made by burning limestone, which is calcium carbonate, which generates carbon dioxide. And you're left with a calcium oxide or hydroxide, which is a stabilizing material. That is naturally unstable at the current sort of ambient environmental conditions and wants to absorb the carbon dioxide back into it and go back to the limestone. So during construction, one has to be very careful in the process that doesn't take place too quickly. And what we do find in many cases is that the top layer does carbonate, and so you get this weak laminated layer on top. Again, there are ways of overcoming it, the construction process. It can be skimmed off with a grader before sealing, all that type of thing. So there are ways of handling it. It's not a major problem, but if the problem is not seen in time and handled, then you can get this lamination or thin layer beneath the seal, which is prone to crushing under wheel loads and things like that. Even the sealing process alone, just rolling the chip into the top of the base can break it up. So it can be a problem, and it will lead to potholes. This is one of our biggest problems, where potholes are seen, teams go out and patch them, but they're not actually treating the cause. All they're doing is superficially fixing the pothole. If the cause is not attacked and solved, then the problem is going to fail again, or the pothole is going to form again. And this is probably the biggest thing that worries the communities and the public, as they see the pothole repair teams over and over at the same potholes, patching them over and over again. One of the main objectives of this guideline is to identify the causes so that when the pothole is repaired, it's repaired properly, and we don't have to keep going back over and over. It costs a lot of money, takes a lot of resources, wastes a lot of materials. A lot of potholes are not done properly, they won't last. But there are other areas as well. It's not just these. Obviously, if there's water as the problem, you need to stop that water. And that often entails the installation of subsurface drains to cut off the water before it gets into the road. We get other areas where trench reinstatements, municipal roads particularly, where a service provider will dig a trench across the road to put in pipes or wires or whatever. They're not normally backfilled and constructed to the same standard as the road, so you get some depression, the trench collapses a little bit, water ponds in that, soaks in, softens the road, and the trench fails. You frequently see potholes along the side of trenches where the join between the trench and the old road is not sealed properly, water goes in there. So there are all these areas. Another big problem one is people putting in a heavily stabilized material, almost a concrete, just by mixing some soil or some aggregate with cement, far too much. We shouldn't use more than about 3%. And you end up with essentially a concrete block in the road. This is going to behave differently under traffic. It's going to rock. It's not going to deflect to the same extent as the traffic, so there's going to be movement at the edges. When it starts opening, crack around this block, water gets in and problems start again. So there are a whole lot of areas of repair that, if they're not carefully controlled, will just lead to bigger problems. The Department of Public Works, they are trying to increase the number of labourers on pothole repair jobs to create jobs. It's a massive opportunity to create lots of jobs. They're looking this year at creating something like 70,000 jobs. A typical pothole repair team would be anything from 10 to 15 people doing different parts of it, compacting, digging, putting in the asphalt, whatever. There are a number of mechanical devices, machines, whatever you want to call them, that go around with 2, maybe 3 people and literally repair a pothole on site. It does not create a lot of jobs, but it's quick. You can probably repair a lot more potholes in the same time, but it does not necessarily solve the underlying problem. You're just filling in the hole. So it's like putting elastoplast over a problem. You're not curing the septic wound underneath it. Right, there are a few basic rules. In the guideline document, we've highlighted, there's a chapter on repair of potholes. And depending on the cause, there'll be different kinds of repair. The preliminary treatment is really the same for all of them, where you identify the pothole, you mark out the area to be fixed. It should not just be the pothole, because water has weakened the area around it, and there's probably cracking associated with it, things like that. So it needs to be much bigger than the pothole. It needs to be marked out. Then one comes on site, you open it up, clean it, cut it out, typically with we're recommending a diamond saw, but the teams that can do equally good jobs with picks. Sometimes you need jackhammers if it's a stabilized layer, for instance. So you need to clean it out, get all the loose material out, get to where you've got the original unaffected road pavement basically, and then start doing the repair. So the preliminary work is actually probably the most important part of it. This is any road project, obviously has got serious safety implications. People working on the road, fast cars, big trucks. We've, in the document again, highlighted some aspects. It's not really a safety document. There's lots of other documents on that, standard procedures. But there are things we've seen on a lot of pothole sites where the cones are so black from bitumen and stuff you can hardly see them, and the safety jackets are dirty and they just don't show up properly. So we're highlighting a few of the basic things like that your flagman should be properly trained, the signboards should be clean, and the right boards, you often see the wrong boards. Yeah, so basically we're just highlighting a couple of the things, but that aspect would normally be under pretty good control of the contractor anyway. Yeah, typically the pothole would be filled with different layers, and then the top layer would be a cold mix or hot mix asphalt. We can talk about that shortly. It's not unusual for potholes up to 100, 200 millimeters deep even, to clean them out and just fill them with hot mix asphalt, but it's expensive. It's far more cost effective to actually put a layer of gravel or stabilized layer or treated material or something else in first and just use the asphalt for the top 50 to 75 millimeters. We get two kinds of asphalt, a cold mix, which comes in bags, which you can use particularly well in rural areas. In urban areas, if you've got a hot mix plant, then it's probably more cost effective. A lot of the metros have their own plants, they can make it. The disadvantage is it's delivered in quite big quantities, and it has to be constructed, put in the hole, compacted before the temperature drops below, depending on the mix, but around about 135 degrees normally. After that, it's difficult to compact. You don't get the density. It remains permeable. So in urban areas, they tend to look at hot mix asphalt. In rural areas, there's no ways you can actually deliver a truck of half a cubic meter to one pothole somewhere. So cold mix is much better. It comes in bags, open the bag, put in the hole and just compact it. The worst thing you can do, and we see this commonly, is to fill a pothole with material from the side of the road. It's often done as a temporary measure until they come and repair the pothole properly. But this usually happens when a pothole gets to a significant depth. Otherwise, they don't worry to patch it. Once vehicles start feeling it, probably 100, 150 millimeters deep, people will take material from the side of the road, put in the pothole. The problem comes when it comes to actually patching it properly. That material is not always removed. So now it's cleaned out up to a point, leveled off, and they put cold mix or something on top of it. But you've still got this really bad, poor, moisture-sensitive material underneath it. So it's not a good idea to use these sort of typical materials you find on the side of the road. They will lead to later problems. The pothole guideline, when we're doing it, we identify that you need to relate the type of repair to the cause. And in the guideline, there's a decision key process where one looks at a pothole and makes a number of decisions, and it's usually a yes, no, or a this or that. It's a choice of two, and you move through the key based on these two decisions each time. And there's 11 steps in the key, and at various points you'll get either moved to the next step or there's a solution. And that could be a shallow repair or deep repair, or asphalt with a deep repair with subsoil drains, for instance. So the document basically defines 6 major types of repair, and the deep ones could or could not have subsoil drainage with them. Subsoil drainage can be a problem because it's quite expensive, needs to be properly designed. You need an engineering input to design it to make sure it's effective. So essentially the repair methods in the document for each of those shallow, medium and deep asphalt, shallow, medium and deep thin surfacing, there's a laid out method in the document, a process to go through how deep you need to go down, what you need to do for each layer, and basically how to repair it. That the classification of the potholes in terms of the type of repair, training for that is being done through the courses we're running with South African Road Federation. They actually repair, and hands-on labour teams who will be repairing it. That training has been done through the Asphalt Academy, where they'll actually go out and do some manual pothole repairs. So there's 2 different aspects to the document. The one is the classification, the other one is the repair. In the document, we go through a fairly rigorous quality control procedure, and it covers a number of things which you can talk about. Firstly, your materials that you use, they need to comply with specifications. So whoever's doing the repair needs to have stockpiles, stores of quality of material of known quality that they can deliver to site fairly quickly as soon as the pothole is noticed, repair it properly. It's no good just putting the material in the road. It's got to be compacted to similar density as everything around it, essentially. So again, there are fairly simple ways of checking that the density has been achieved. And we've highlighted these in the document as well. I mentioned earlier the asphalt, that has to be compacted at a hot temperature. If it's too cold, it will not compact, you will not get density. So again, it's another simple quality procedure. You just get a simple thermometer, shove it in the asphalt before it goes in the hole and check that the temperature is adequate. If it's not, that's got to be thrown away. You can't reheat it or anything. It's wasted. Riding quality, you often see in roads that are fairly significantly patched, ups and downs and lumps and bumps, and the vehicles start moving up and down. This gives dynamic forces, dynamic loads on the road further down. So if the road is already fairly weak, that's why it's potholing, then it's going to generate more potholes further down the road. So we need to get as smooth a patch as possible so we don't generate this dynamic movement in the vehicles. One of the things that's come out as well is the join between the patch and the old road or the existing road. And a lot of the problems start, that join opens up with time and can be fairly quick, a few months even. Water gets in and the existing road starts failing rapidly. So you get a pothole at that join. And again, there are ways of handling this. And one of the ones we're recommending, based on a number of observations, is to put what they call geosynthetic strip over that joint, tack it down, and it seals it and waterproofs that strip. So even if it does open slightly, it's still a waterproof joint. So it's fairly simple things like that. And the last thing probably discussed under the quality control here is the aesthetics. The job needs to look professional. We don't want lumps of black bitumen in a grey mess. It needs to be nice, square or round, although round is very difficult to make. We're suggesting square, rectangular or diamond-shaped patches in the document. They just look more professional and better engineered work. Yeah, so that's essentially the quality control. And up to now, that hasn't been a major thing in pothole patching. But hopefully now, through the courses, people are saying that's what we need. We need to check that quality. One of the problems with quality as well is that it needs to be monitored at different stages. Compaction in a hole has to be monitored before the next layer comes in. Whereas adhesion, for instance, of a geosynthetic strip to the surface, that probably takes 3 or 4 weeks to actually bond and stick down. So there's different times that different things need to be controlled. And that's one of the dilemmas now. Who controls compaction? The contractor? Or do we have an engineer or inspector on site the whole time? And this is one of the things that needs to be sorted out. We're trying to have a sort of standard record where the contractor will mark things. One can go back later and check if he did try and pull the wool over everybody's eyes, which could or could not happen. But again, we're also saying the contractor should give some kind of product performance guarantee. That if he patches the hole, both the workmanship and the cold mix or hot mix or whatever he's putting on top needs to be guaranteed for a year or 2 years or whatever they decide in the contract. And that'll put the onus on the contractor to make sure the job is done properly. And this is not a new thing. It's over the years it's becoming more and more used. So it's not unusual, but this does make sure that the contractor, he may charge a little bit more initially, but you won't have to go back 3 or 4 times. What we're suggesting at the technical guide should be implemented by an engineer, or at least somebody with some engineering background, a qualified, experienced road inspector, something like that. That will make sure that the cause and the type of pothole repair required is identified correctly. So that's going to solve one of the problems. The engineer would normally specify that's the kind of repair, go out and do it. Whether he will come back or somebody else will come back and check the quality, the engineer could do it. Let's say it could be quite costly that way. Or somebody else could be appointed, specifically an independent assessor, goes out and checks quality. So there's different ways of doing this. It's interesting because if we look at the road network in South Africa, I think more than 80% of the road is long past its design life. A road is designed for 20 years. If you get 25 years, you're probably doing well. There are roads 50, 60 years old that are still there. They're still structurally sound, but they're giving problems because they haven't been maintained, that's all. The cracks have not been sealed. In the length of road built in the last 10 years is probably minimal in terms of overall, 200,000 kilometers of paved road that we've got in South Africa. So our biggest challenge is this aging network. And we've seen the asset value of the paved road network is probably around about 800 billion rand. That's what it costs us to replace the paved roads now. We should be spending probably, if we say it needs maintenance every 7 years, we should be spending probably 100 billion plus per year on maintenance. And currently I think we're spending around about 30 billion. So we're falling behind. And the more we fall behind, and this is exactly what I said earlier, in Australia and America, the problem with road maintenance is there's no immediate political benefit. The benefit is only shown 10 years' time when you've still got a road. But by then most politicians and managers and people have moved out of the system. It's not their problem anymore. And these are the challenges one needs to overcome to be able to spend some money on something that you're not going to see any benefit on. Yeah, obviously budget's a big challenge. I think everybody recognises the problem now. I've actually been down to the Parliamentary Portfolio Committee on Transport together with the major road authorities and people, and the chairman of that portfolio committee actually was really interested in what we were saying in terms of budgets and amounts of money needed and what's causing the problems. So I think at least now the politicians understand the problem. That's the main thing. Whether, I mean, I mentioned just now, we probably need more than 100 billion a year just to keep up, let alone kill the backlog. Whether that'll ever materialise is another problem. It's got to come from somewhere, yeah. Most university engineering courses have a transportation or a road design module. It's fairly superficial. I think it gives them the basic understanding, but it's really the structural design of roads and the rehabilitation. There's very little in terms of maintenance, hands-on type things like pothole repair and stuff. There are courses, Road Federation run a number of road maintenance courses. This document has been seen by the university people now, and they're dishing it out, for instance, as part of the course in a number of cases. So I think the awareness is there, but one of our biggest problems is, say, the pavement engineers. They're very limited. Most of them, one goes back to university and does an honours degree to become a pavement engineer. The technical universities, the roads, again, a very superficial, general pavement design, simple principles, transportation engineering, thing like that, but probably not enough to make anyone a specialist pavement engineer. And that is our problem. In South Africa, in terms of number of specialist pavement engineers, we're very thin on the ground. We all know the sort of skills gap currently in South Africa, where there's a large or a pool of plus 50 sort of white engineers, and then there's a fair gap, and then there's a pool of probably minus 35, minus 30 black engineers. A lot of them are Technicon trained, university trained, so they just do not have experience yet to do what the sort of older generation is doing. So there's this skills gap there, and that's our biggest challenge, is to transfer the current skills down to the emerging engineers. And hopefully books like this document will help in that respect. Well, that's a sore point. Now, we need to be looking, over the last probably 15, 20 years, the proliferation of heavy vehicles, large trucks on our roads. I mean, everybody sees it, everybody complains about it. In the traffic jams, morning traffic jams, there's big 7-axle trucks stuck in the middle. And the movement of freight from train to truck has just increased exponentially. My personal opinion, and I think a lot of people agree, is that we need to get that freight back onto rail. We need to upgrade the rail network, get as much freight as possible back onto rail, and keep the roads for light delivery and for commuter type traffic. We know that you can never solve the congestion problem by making more roads, making wider, more lanes. It doesn't solve the congestion problem. It just attracts more traffic. So the only way is to try and get the slow-moving heavy vehicles off the road. Yeah, I think the GFIP Gauteng Freeway Improvement Program is certainly going to alleviate some of the congestion problems. on the highways. It's not going to alleviate the congestion problems getting off the highways, because the roads, once you get off, they have not been upgraded in most cases. So the problems are going to be at the interchanges. But at least with 4 or 5 lanes, the traffic will move a bit quicker. So I think that's a good step. In terms of the tolls, probably at first there'll be a bit of resistance, but when tolls first started in the late 70s in KwaZulu-Natal, people were taking all the back roads, but they soon learn it's actually much quicker and cheaper to go on the toll road. Yeah. The Gautrain certainly is going to alleviate a lot of the congestion in peak hour between Pretoria and Joburg. I think that's a great system. I personally hope and probably think that it will be expanded at both ends into ultimately an underground system for Joburg. That's the way it's got to go. Joburg needs some kind of mass transit system like that, so that's a good starting point. And probably Pretoria down the line as well, but, so that's open to conjecture. The first thing we need to do, and I think government has recognised the problem now, and the whole pothole problem is a result of neglecting road maintenance over the last 10, 15 years. Say 15 years ago, every province had a pavement management system where every year data was collected, it was put through the system, and it came out saying this road, that road needs some kind of maintenance. And it allowed budget allocations or budgeting calculations. Whether they got the money or not was another problem. But at least you could see how much money you needed and how much you're getting. In the last, say, 10, 12 years, those pavement management systems have all gone. The only one left is Sanral. They've still got an effective one, and you can see that in the standard of their roads. And the Western Cape have got still a functioning pavement management system. No other province has, or to the best of my knowledge anyway. And that's why we cannot predict what roads need maintenance, where, when, how much it's going to cost. So until we get pavement management systems going again, so at least the budgeting can be done correctly and say we need so much to maintain our roads and to catch up the backlog, we're going to have a problem. So the future, I think, is basically one needs to reinstate those systems. So they're fairly simple things these days. Originally, in the old days, of small, big mainframe computers and things, it was a major exercise. But with PCs on the desk, and I mean, even your cell phone in your pocket, you can probably run one of these systems these days. So I think it's going to be an increase in those, which hopefully will allow better budgeting and more preventative maintenance. Because without that preventative maintenance, we're going to lose our road network with time. Say the trucks, whether they stay or go, I don't know. There's a lot of people employed, a lot of money invested in the trucking industry. I can't see it just be changed overnight. But until the railways becomes more effective, that's not going to happen. If one could send goods cheaper by rail, then it would look after itself.